Let's look at another example of binomial distribution. Okay, problem number 2-34. If 10% of all disk drives produced on an assembly line are defective, what is the probability that there will be exactly one defective in a random sample of 5? So 10%, the rate of defective is 10%, so you're taking a random sample of 5. So each disk drive can be either defective or not defective. So here the success is defined as, okay, so here what is success? Success is disk drive is defective. That is success. Now n is 5. P, probability of success, is 0.1, 10%. So Q is 1 minus that. Okay. And the probability that we want is that exactly of the 5, exactly 1 will be defective. So R is 1. So probability of x equal to R or x equal to 1. So we will use the binomial distribution. Okay. Binom.dist. Okay, so there is another binomial distribution function at the bottom. You see with a yellow warning sign. So this is a legacy function pre-2007, Excel 2007, I think. I don't know when exactly the new functions were introduced. So you should not use the legacy function ever. So always use the new functions. So binom.dist. Okay, number of success is the first one. So that's that. And then trials. Okay, so I'm going to make that absolute reference. Okay, that's n, number of trials. And then P is C46. Again, I'll make that absolute reference. So when we can copy this formula for other problems. Well, I forgot to put whether I need cumulative or individual. So we want individual here. If I put cumulative, then we will end up with the probability of x less than or equal to 1. So that will be probability of x equal to 0 plus probability of x equal to 1. So we want 0. Okay, so that's the probability. Okay, let's have 4 decimal places. Now, second question, what is the probability that there will be 0 defects in a random sample of 5? So which means we want R equal to 0. So now we can copy this because we have the N and the P absolute referenced. So we can copy that down here and we get the probability of R equal to 0. Okay, next is what is the probability that there will be at least one defective in 5? Okay, at least one is 1 or more. So you can get x equal to 1, x equal to 2, 3, 4, 5. You can individually compute these 5 probabilities and sum them. Or an easier way of doing this is greater than or equal to 1 is the opposite of x equal to 0. So since in a sample space all probabilities must sum to 1, we can always do this 1 minus probability of x equal to 0, which is that. So this should be 0 here. Okay, so 1 minus probability of x equal to 0 will give you a probability of at least one defective. Next question, what is the probability that there will be between 2 and 4 defectives? So we have R1 is 2, R sub 2 is 4. Okay, so we want between 2 and 4. Okay, so it's like this. So we have zero, 1, 2, 3, 4, and 5, right? So we want that probability. Okay. Of course, we can compute the three probabilities, probability of x equal to 2, x equal to 3, x equal to 4, and add them up. Or we can do this. Um, so okay, so we'll first compute individual probabilities and add them up. So here I have to set up the formula again. Binomial distribution, number of success, comma, n should be absolute referenced, p should be absolute referenced, and then 0 for individual probability. Okay, and then we can do this. All right. And then the probability that we want is sum of these three probabilities. Okay, so that's good. Or we can do it, we can compute the same probability in a slightly different way. So we want these, right? We can set up the binomial probability as a cumulative probability. In this case, there are only 5, so computing 3 probabilities is no big deal. But if you have like several probabilities to compute, you don't want to be able, you don't want to set up a big table of all the different R values. So instead, we can use cumulative probability. So we can look at cumulative probability of R equal to 4. So that will take the probabilities from 4 all the way to 0. Then we can subtract these two probabilities from it. So if you set up R equal to 4 and you want these two probabilities to go, so R equal to 1. Okay, so that's what you need. Now I can copy this formula here, except that I have to change the 0 to a 1, so we'll get cumulative probability. Okay, it's not exactly equal to 1, it's very close to 1. Okay, so now we can subtract one from the other. That minus that will give you the probability that we are looking for.